Hey guys, so today you and I are going to talk about unit testing. So let's get into it. So the question in question was, hi Frederick, when you refactor code that does not have any unit tests, do you write the unit test before you do the refactor? Sometimes, if I can, but usually it's not possible. Uh, so if there are no unit tests, if I'm really lucky, the thing that I'm refactoring is like a function or something like that, which is great because usually, adding tests to an already existing function is pretty straightforward. And in that case, yes, then I add the unit test first. The reason why I do that is because the purpose of the unit test is to act as a snapshot, or as like basically an assertion of correctness at any given time. And as you can imagine, if I have a bunch of untested code, and unless that code is fairly simple and I kind of know how it should work, it's actually a little bit difficult for me to verify if I broke it when I change it, because I can cause a regression for any change that I make. So what I want is to have the unit test there in place before I make the change, to make sure that the functionality is still what it should be before I do the refactor. And that's the whole purpose of having unit tests, so that if because you're basically testing the behavior, or you're testing the implementation, so that the implementation stays the same even if you refactor the code. So you can change in this case, the function 100 times over, but if the output is always the same and it's always abiding by the rules that you added in the test, so that the tests are still passing, you don't have to worry, because now it's that this function is still going to behave as the original author of the code intended, right? So if it is possible, I do that, but usually, unfortunately, it's not, because the times you do refactors are, in many cases, down to like fixing legacy. And when you fix legacy, it's usually that the code is completely untested and it's untestable. And that is it's the norm for me. I've never really been in a project where a refactor was necessary without that sort of issue being there. And in that scenario, the code is so poorly written that actually writing the test first is not going to work. So what you have to do, and what I usually do, is that I try to look at the refactor as a lift and shift type of deal. So I look at the code that is bad and I identify the pieces that I can test, and then I break them out from the whole structure, right? So I usually do a divide and conquer type of thing. I split out the functionality that is really ugly or like is poorly written or so forth, and then I test that individual piece. The reason why I want to do that is because if I'm forced to refactor something, I want to make sure that the scope of what I'm refactoring is as small as humanly possible until I can get the test on top. Because as you can imagine, if you're refactoring like an entire module, like an entire code base of stuff, it's going to be really tricky for you to not make a mistake when you're changing things in all the places at the same time. But on the other hand, if you start with just a function, let's say a function in a big class or like a big file or something like that, and you just move that out, isolate it, and you refactor that one function so that it can be tested, the likelihood of you making a mistake there is actually very small in comparison to changing all the things, right? And then you add a test to that thing, and then you repeat that process. This is why I love the Boy Scouting rule, because if you just make a commitment to making sure that when you're making refactoring changes to a large system that is untested, if you simply try to focus on piece by piece rather than big things, it's lower risk for you, each thing you're fixing, and at the same time you're actually getting to the end goal anyway. A lot of the software developers have this thing where they want to they're trying to optimize for silly things, in my opinion, at the very least. Oh, I don't want my pipeline to run, it takes too long, and oh, everything takes longer when you have to do these small commits or like small changes. And I kind of go, yeah, but it's not gonna break, which is more important. that the pipeline, you don't have to merge as many times or things like that, or that the code is working. It's, you know, I can never really understand the software developers that I work with that think that way. I get it. It's just that it's in my personal opinion, it's a sign of great immaturity and unprofessionalism from the person that I'm talking to, because it's very clear to me that they seem to have forgotten the purpose as to what they're doing, and the fact that, like, how do I put this, they've made the software development thing, the thing that they're doing is about them now. It's not about what's good for the product. It's not about what's good for the software, like the whole. It's about, oh, I find this annoying, therefore I will not do it. I mean, shit, in some occupations you would get shot for that sort of mindset. It's unfortunately it's there. But the facts are, and it's been proven many times over, that making small incremental changes is a more stable and safe way of doing development. Even though it might add a little bit of overhead to your overall process, it's still a very solid method. It's the method that I use as well. I mean, you don't have to like make a small change, create a few tests to a single function, then commit that into the code base if you don't want to, but you can start by just doing that and then committing that in your branch and then repeating it until you've refactored the whole module, and then you can merge it. It's more about the process, and that's where the difference between writing unit tests and doing test-driven development, that's sort of where that comes in, because the quality of the test and the likelihood that you have tested the right things and that you actually capture the things that are important goes up with test-driven development, simply because you have written the test before you write the function, which means that you are more likely to catch like all the cases that you're looking for. But if you write the test afterwards, you're more likely to just write tests that fit your current implementation rather than think about what is the overall intention of the thing that I'm working with. And in this scenario, it's actually the same sort of thing, because if the tests were there before I did the refactor, then I wouldn't have to be so worried that I'm going to make a regression, because the tests are already there. But since they're not already there, now I'm a little bit in like, if it's a dangerous change, I don't really know if I'm breaking it. And that's why I need to get the tests in place to check the implementation as quickly as possible with as little risk when I'm kind of touching it without the test. And that's why I tell people, if you just make the minimum thing, if you just change the smallest piece that you can, make the code, you refactor enough of the thing so that it's testable, and then you write the test, that's almost as good as if the person who wrote the original implementation had done it from the start. So what I want you to take away from this is that I try to write unit tests if it's possible before I refactor, because basically I want to have an assurance that I don't cause a regression when I do my own refactor, because it's every refactor, every code change can cause a bug in some fashion, and that's why we do testing in the first place. Sometimes it's not possible, and in the cases where it's not possible to write the test first, I do a lift and shift, where I just take the current implementation as is. I don't refactor anything. I just take the smallest piece that I can find and see if I can write tests for that specific piece of the logic. If I can't, I at least have a very small area that I'm changing, so that I can easily figure out if I broke something. Well, I know exactly where I touched the code, so I can figure out why did that break, and then I can make sure that when I'm changing that piece of the code, as soon as I'm in a state where that single piece can be tested, I add the test, and then I commit, and then I repeat that process. So instead of trying to refactor all the things at the same time, I just focus on one little piece, and then when that's tested and I'm happy that yes, I understand that piece of logic now, it's well tested, I move on to the next piece. This is also a very good way for you to learn a code base, because by having this approach of adding tests and refactors and so forth, you're going to get to like really laser focus on a specific piece of like a big system, and by just taking it piece by piece, you're actually learning how the whole architecture of the system works. So there are a few benefits to having this approach, and I find this to be the most effective way to take a code base from like legacy or like bad state over to a very clean, well-tested system. Have a great day.